If we want to look at Faraday's law in quantitative electrolysis, okay, what Faraday's law states is that the amount of substance produced or consumed in an electrolysis reaction is directly proportional to the quantity of electricity that flows through the circuit. So what we need to know in order to determine the amount of substance that's produced is we need to know the quantity of electricity that has flowed through the circuit. And to do that, we need to find the coulombs, and the coulombs of charge are determined by taking the current that's been applied and multiplying it by the time in seconds. Okay, so if we take the current and the time, we can use that to find the charge by multiplying by time. Okay. Using the charge, we know Faraday's constant of 9.65 times 10 to the 4 coulombs per mole of electrons. So if we know how much charge has been passed through, we can determine how many moles of electrons were actually used in the reaction. Okay, and then we've got our moles connection. So we've got a half reaction that's going to have moles in it. So we're going to be able to figure out the moles of the substance and therefore the grams. Okay, so the easiest thing to do is to look at an example here. So we've got a current of 0.452 being passed through molten calcium chloride in an electrolytic cell for 1.5 hours. How much product will be formed at the anode and at the cathode? Okay, so we've got molten calcium chloride, so we can figure out the half reaction. So at the cathode, we've got calcium gaining electrons, and at the anode, we've got chlorine losing electrons. We can figure out the charge by taking the current, which is 0.452, and multiplying it by the time in seconds. So we've got 1.5 hours times 60 to convert that to seconds. So we've got 2440 coulombs of charge. So once we know the charge, we can determine the number of moles of electrons, because we know that 9.65 times 10 to the 4 is the amount of coulombs per mole. Okay, so the moles of electrons can be determined by taking the charge, okay, and dividing it by Faraday's constant. So you've got 2.440 divided by 9.65 times 10 to the 4 coulombs per mole. Okay, and that will give us the moles. So in this case, 0.02529 moles of electrons. Okay, so that's the number of moles that were transferred, okay, during the 1.5 hours. Now we've gotten it to the point where it's stoichiometry. You know how many moles, for every 2 moles of electrons that were transferred to the calcium, 1 mole of calcium is produced. Okay? For every 2 moles of electrons, 1 mole of chlorine was produced. Okay, so the moles of calcium and of chlorine is found by taking the moles of electrons and dividing by 2, because we have a 2-to-1 ratio there. Okay, so that's the moles of calcium. So then from that, you can figure out the mass of the calcium of 0.506 by multiplying by its molar mass, or the mass of the chlorine by multiplying by its molar mass of 0.897. Okay, so that's the approach to solving quantitative electrolysis problems.